Okay, in our previous videos, we were discussing solving linear systems. Now, when we solve linear systems, we find points of intersection. And there were methods to solving linear systems. What were they? Well, they were graphing, substitution, and elimination. Now, we talked about substitution in our last video, and in this video, we will be talking about elimination. Now, elimination could be more difficult to understand than substitution, but the process, what I find the process with elimination is actually much easier once you understand what the process is actually asking you to do. So, in the substitution method, I had steps. In the elimination method, I also have steps, and these are very helpful for understanding the process, that once you have a question where you have to solve a linear system, meaning find x and y, you can follow these steps and then get to your final answer. So step one, here's what you do. Are any of the numbers in front of either x or y the same between the two equations? You have to ask yourself that question, right? So I'm given a linear system as an example, given this linear system, and I want to ask myself, is any number, and by number I mean the digit, is any digit in front of any letter the same? If yes, then I can move on to step 3, right? So in this example, notice that I have a 3 right in front of both y variables. So I say, yes, the numbers in front of y are both 3. Forget about the fact that one's a negative 3, the other one's a positive 3. I just want to know if the digits are the same. Then I can move on to step 3. Step 3 would then be to add or subtract the equations to eliminate one of your letters. Isolate for the remaining letter, and I'm going to explain what that is. So in this case, I noted that both the signs are different, right? One's a minus, one's a plus. If I were to add the equations term by term, these two y's would actually cancel, because negative 3 plus 3 is 0. They cancel. In the end, I would get 2x plus x, which is 3x, equals to 6 plus 4, which is 10. So I'd get 3x equal to 10, and I could solve for x. That is basically step 3. Okay. And once I get x, I could substitute this letter back into the other equation to get the last letter, in this case, y. Okay? Now, what if I don't have the digits the same? What do? Well, instead of jumping from step 1 to step 3, I go on to step 2. Here's what I would have to do. I'd have to multiply either one of the equations or both of the equations by a number, and the numbers don't necessarily have to be the same between the two equations, in order to make the numbers in front of x and y or y the same. So we have an example here. I'm given this base example, and forget about that times 2 and forget about this times 2. So my equation is x minus 2y equals 3 and 2x plus 3y equals 2. Notice that none of the letters have digits equaling each other, right? X has 1 and 2, y has 2 and 3. None of them are the same. But if I multiplied the top equation, if I multiplied each term by 2, what would I get? Well, the first equation would turn into 2x minus 4y equals 6. Notice how I've multiplied every single term by 2. The second equation remains unchanged. Now, I've completed step 2, and I can jump to step 3, which is add or subtract the equations. In this example, I added the two equations, and my y variables canceled. In this example, if I were to add these two equations, my x variables would not cancel each other. I'd get 4x equals to y, or sorry, 4x minus y equals to 8. Instead, what I'm going to do is I'm going to subtract the equations in order to eliminate the x. And I know this might sound confusing, but we'll do some examples together. Like I said, once you understand the process, you're good to go. Example 1. This is the linear system I have to solve by elimination. Now, ask yourself, are any of the digits the same between the two letters? Yes, I've got the numbers in front of y equaling each other. That's perfect. So I can jump right ahead to step 3. The numbers in front of y match. Great. Now, the signs are opposite each other, so I can add equation 1 and 2. So I do just that. 2x plus x is 3x. These two will cancel each other or eliminate each other, hence the process is called elimination. They will eliminate each other. Then I will add 8 and 4 and I get 12. So in the end, I get 3x equals 12. Now I can isolate for x by dividing both sides by 3 and I get x equals 4. Step 4 in this process is to take x, which is equal to 4, and substitute that into either of the first two equations. Doesn't matter. So I plug it into what looks to be the easiest one, which is equation 2. And I punch in x equals 4. So I've replaced x with 4. And now I've got an equation for y. And I can isolate for y. So I do just that. And I move the 4 over, which means I just subtract both sides by 4. And I get 3y equals to 4 minus 4. 4 minus 4 is 0. So 3y equals 0. If I divide both sides by 3, I end up getting y equals 0. Now I've gotten an x value, and I've gotten a y value, and that's pretty much all I need to find because that's my point of intersection. So I do a check, and I'm going to substitute x equals 4, y equals 0 into both the original equations. Plug in x equals 4, which means I substitute, and I plug in y equals 0. Once I punch it in, I get 8 equals 8 in the first equation, left side equals right side. In the second equation, I get 4 plus 3 times 0, 4 plus 0 is 4, 4 equals 4, and left side equals right side. And ladies and gentlemen, that is the process of elimination. So like I said, it's easy once you understand the process, but understanding the process takes practice. So I would recommend that you practice some of these examples, solve for x and y, and once you get the hang of it, elimination should be a much easier approach than, say, substitution, in my opinion. But it depends on who you are. Anyways, thanks for tuning in. Bye-bye.